Hey, I've been working on the laser shooting simulator system. And originally I showed a video where you take a pistol and you convert it to fire laser beams instead of bullets. And then there's videos about the coming up with the targets that the laser beam would hit. This one's the Cree diffuser and collector. Then there's a video about the circuit board that processes the signal, amplifies it, gives me a digital output, and turns an internal LED here on and off, showing whether the target's been hit. And then the last video I did, kind of the key puzzle piece, is the timer. This is a digital stopwatch, and this will be used to give you a score, like down to the 1/100th of a second, and how long it takes you to clear the set of targets that you're shooting. And so I went in and opened up. This is just a standard electronic stopwatch. I opened it up and added in a external input to it, which basically gives me the start-stop function, but remotely. And I'm going to remotely connect that into this circuit here, and this will give me the score of a measurable result that you can use to gauge if you're improving or what you can do to improve your scores when you're in a competition shooting match. And so today what I did, I took this circuit here and did a schematic diagram of the complete system, and I laid it out on a PC board. And I ordered the PC board, and it's being fabricated right now. And I'll show you what the board looks like right now. Okay, here we're in here on my CAD workstation, and this is the schematic of the laser two-gun simulator. And I decided to make it in groups of 4, so each board will support 4 targets. So there's one LM324 op-amp chip which can support 4 targets there. And so there's 4 opto-isolators here. And you notice there's an extra one here. This one actually exists to drive the stopwatch start and stop timer. And the only other connections are there's 6 volts here for the supply. And each one of these LED connections, they will go to an LED bank inside the target, and it will make the target glow green when you strike it with a laser. And here you'll notice these are the LDR sensors. They will actually be remotely located inside the diffuser target itself. And these are the potentiometers that you use to adjust for the ambient light. And so next I'm going to show you the actual PC board that I laid out today. So here's the actual PC board layout. It's about 2.5 inches by 3 inches approximately. And here, these are the opto-isolator chips. There's the 4 here. And the 5th one here drives the stopwatch output. And this is the one LM324A optic. This is a quad op-amp chip. So there's 4 amplifier chips in there. And these are the 4 potentiometers to adjust for ambient light. And here's the 6 volts plus and ground. And these are the connections here that will go to the LED banks located inside the target. And these connections here are for the LDR, the light dependent resistor sensors that will also be mounted in the target. And so this is the layout. These big holes here, these are just mounting holes. And so this is a 2-layer board, pretty simple to lay out, and having that manufactured right now by Express Circuits.